Good morning class. Welcome to the online classes for physics of class 11th. Here we have started the chapter. In the previous video you may have seen that chapter 11, which was named as thermal properties of matter. In the previous post-midterm portion we have seen that the mechanical properties of solids and the fluid, that means of matter itself. So what that mechanical property was considered as, that is the whenever the force is applied on any body, the particles get a kinetic energy, that means they are coming into the motion. So when we just study about that motion of the particles inside a matter, then it is considered as a mechanical property or a mechanical physics of that particular matters, particles and its energies. Now we are seeing that thermal properties means now we are going to see that how these particles will affect due to the temperature and the heat. Okay. Now we know that what was the heat, that is the transfer of energy, means we used to say that heat is a form of energy. But why it is a form of energy? Because it can neither be created nor be destroyed, because it is just transferring from one body to the other. So this transfer of energy, that's why it is considered as a form of energy. So this is what the transfer of heat is in the form of a energy. And what this temperature means, that is the degree of hotness, means how much hot or how much cold, what the heat of the body can be measured is considered as the temperature. So it is just the degree of hotness of a body or a measurement of a hotness of a body. So what heat or how much heat the body have is considered as a temperature. So that is what the difference between the heat and the temperature. That is, temperature will be the measurement of the heat, and heat is a form of energy that gets transferred, and this heat can transfer between two systems or between a system and a surrounding. And what the system means, that is system, if we consider a body in which we have to study about the particles and its effect due to the temperature, then that body is considered as a system. And if you talk about what the surrounding is, then except that system, whatever is in the environment, that is considered as a surrounding. So the area around that system will be considered as a surrounding, and the particular body which we have to study is considered as a system. So the heat difference means the temperature difference will be there between the heat, and that is heat in the system and the surrounding. So this transfer of heat between the system and the surrounding is considered as a heat transfer. Okay, so till this temperature difference will take place till the temperatures of both the body will not get the similar, means if the bodies both of them get similar, then we can say that the temperature difference is almost same, so the heat transfer will stop. Similar, I given you an example that we take a cup of tea, then it just is very hot, but if we take in the summer, then it will take time to get cool, and if we take in the winter season, it will get cool in seconds. Why? Because the temperature outside the surrounding will have the transfer with this cup of tea, and since the outer temperature is less than that of the cup of tea, so this heat will be going to the surrounding. And if this is outer surrounding is having, like in a summer season, it will be having the high temperature. So our bodies, that means the system, that is a cup of tea, this heat will get transferred to that of the surrounding, but it will take time because it's already heat and our tea is also heat. That's why you used to prefer the cold drinks, means it should have a less temperature so that it can get almost melt, because if you used to eat ice creams in the summer, it used to get melt. Why? Because it's already having the temperature which is less, and outside the surrounding we are having a hot temperature, so both will try to temperature difference, means they will try to transfer heat to each other, due to which the body will get heat now, because already the summer season we are having a high temperature, so the ice cream's temperature will also be somewhat increased. Already it was freezed, that means it was very in a cold very temperature, and that very cold temperature will now become a heat, somewhat it will, the temperature will be increasing. That means this temperature difference between the system and the surrounding will try to melt that part. So that is what the temperature difference is there between the two bodies. It may be system and surrounding, or between two systems. Okay, and we have seen the different measurements for the temperature, that one was Fahrenheit scale, one was Celsius scale, and one was Kelvin scale. So there are different scales for the measurement of the temperature. First, if you talk about the degree Celsius, then we know that the body which get icing, and one will be the steam point. One ice point means the body when it will start getting freezed, when the point where it will start getting freezed. And if you talk about the boiling point, that means how time when it will get boiled and it will be changing into the steam. So that is the steam point. So this in degree Celsius it will be 0 degree Celsius, and for Celsius, the highest point, that is the steam point, will be 100 degrees Celsius. So this is what the temperature difference between the lower point and the upper fixed point of the temperature. For Fahrenheit, it is different. That is, it will start by 32 degree Fahrenheit. Sorry. 32 degree Fahrenheit to that of 212 degree Fahrenheit. So this is what the change, the temperature difference between the lower fixed point and that to the higher fixed point of the Fahrenheit. So the temperature difference is of 180 degree. Here it is of 100 degree. Now if I talk about Kelvin, then it will be 273, the lower fixed point, and higher fixed point will be 373 degree Kelvin. Okay, so this was the change. We will be considering it as a 100 degrees Celsius temperature difference. So from here we can give that formula for the conversion of the temperature between the different scales, like degree Celsius can be changed into Kelvin, Fahrenheit can be changed into Kelvin, or a Celsius can be changed into a Kelvin. We know that temperature like C minus 0 means degree Celsius minus lower fixed point upon the higher fixed point. Hence temperature difference. Now if we talk about Fahrenheit, then it will be Fahrenheit minus lower was 32, the difference was 180, equals to Kelvin was of 273 lower point, and if we talk about temperature difference, then it was 100. So this is how we can convert. If you know these temperatures, we can use the formula for the conversion. Like if now I want to change the degree Celsius into Kelvin, so what I will do, C minus 0 upon 100 will be equal to that of K minus 273 upon 100. So 100 and 100 will be cancelled. C minus 0 will be C and K minus 273. So these 273 will get plus over there. So Kelvin, now the degree Celsius will be changed into Kelvin by adding 273 to it. And if I want to change this Kelvin into degree Celsius, and these two equations will be compared to each other, due to which we can say that Celsius will be almost, when we want to change this Kelvin into Celsius, it will be minus 273. So this is how we can just convert the temperatures. And if you talk about Fahrenheit and the degree Celsius, we know C minus 0 upon 100, and for Fahrenheit it is F minus 32 upon 180. So now the C minus 0 will be C by 100 equals to 1 by 180, or in F minus 32. Now 100 will be crossed out. The C is equals to 100 upon 180 and F minus 32. So on cancelling we know that it will be 2 5 and this will be 2 9. So C will be equals to 5 by 9 F minus 32. This is what the conversions that we can convert a Celsius scales or into Fahrenheit or into a Kelvin. This is what the formula for the degree Celsius and the conversions of the temperatures. Now we will see ideal gas equation. I already told that any ideal gas, if we talk about, then we are talking about the temperature. If we are increasing the temperature on any body, there is some effect on the particles, and these particles get affected by the temperature, due to which their kinetic energy increases. But if we talk about a fixed volume, like we are having a solid which have a fixed volume and fixed size and shape, so there the expansion will be less, but the particles will try to move. So there is a motion in the particles due to the temperature difference. And similarly, if the particles are moving, that means we are applying the force, and that in the particular that area in which the particles are moving. So particles are getting out the pressure, means there is a change in the pressure due to the temperature. So when we increase the temperature, the pressure of the body is also increased, due to which there may be change in the volume also. Like if we are applying a temperature difference, we are applying a heat to the normal water, we know that the water gets heated and it almost converted into the steam, and it get evaporated. So these steam, if it is hot, then they will escape very fast, and if it is very close, we know that freezers, when you take out something from the freezers, or from like you are buying any ice creams from the shops, they have a lot density, like if you have seen that cold steams, the density is very high. That means we can easily see what the vapors are like, and if you talk about the heat, that the hot steams, then it escape very fast. So that is what the different form of the steams and the energies. But here we are going to see what the change in the pressure and the volume. We know that the pressure is changed, similarly the volume of the body is also changed. But if you talk about a fixed volume, like if we just covered it in some particular one utensil, then the volume could not be changed of a gas. Like if you are applying a pressure or temperature, then also the body's gas will not get that much kinetic energy. It will try to strike the body, then they will be applying the pressure on the surface, but it cannot get out of the surface. So they will be try to move, or their kinetic energy will be increased inside the body. Now by the Boyle's law and the Charles law, we can tell us about the ideal gas equation, What was the Boyle's law? That pressure into volume will be constant. And if we talk about the Charles law, he was given that V upon T is equals to constant. And on mixing these two equations, we will get that PV by T equals to constant. And this constant was given by R, that was a gas constant. And on taking this T on that side, it will be RT. Since we are taking a gas, so which type of gas we are using, like monatomic, diatomic gases, what is the moles, what you are considering the number of the moles for the gas, so that is what the N will be number of moles, and this is what the ideal gas equation is. And these gas constant will have the different values for a monatomic gas and the diatomic gas, but we used to use 8.314, and it will be joule per mole per Kelvin. Like this is what the formula for the ideal gas equation, and we can use this for the different values also, and you will be studying this same ideal gas equation in the chemistry also. Okay, so this is what the PV is equals to mu RT it is given as, but you can use its nRT or mu RT, but that is was the number of the moles of the gas which we are using, and R is the universal gas constant which is given by 8.314. Okay, so in the next class we will be seeing the thermal expansion and how the thermal expansion can affect. Means thermal expansion means as we apply the temperature to any body, there is the kinetic energy to the particles, means we are applying the force and the bodies are getting in the motion, and that too with moving with a high speed. So that is what the kinetic energy of the particle is, and on the movement of the particles there would be expansion in the linearly, means in the length, it may be volume or it may be surface area. Depending on that, the thermal expansion can be of three types, that will be linear expansion, superficial expansion, that is surface area, and the volumetric expansion. So this we will be seeing in the next class. So thank you class.